Hello everybody, thanks for joining today's webinar about changes to Utah's residential energy code. My name is Kevin Emerson. I'm the Senior Policy and Regulatory Associate for Utah Clean Energy. I want to start with a quick housekeeping. This webinar is scheduled to conclude at 2:30, and a copy of the presentation slides will be sent to participants after the webinar. We're recording the webinar and it'll be available for viewing afterwards. And throughout the webinar, please note your questions and reserve your questions for the discussion and questions portion at the close of the webinar. As your questions come up, you're welcome to enter your questions into the question box, which is on the sidebar of the webinar screen. As many of you know, last week, July 11th, the Uniform Building Code Commission sent certification to the Utah Legislature that Utah now has a working version of ResCheck, which makes the updated residential energy code take effect on July 1st, 2014. I'll talk a little bit more about these kinds of details in a moment, but first I wanted to introduce Utah Clean Energy and SWEEP very briefly. Utah Clean Energy is a Utah-based 501c3 nonprofit organization founded in 2001. We work to stop energy waste, create clean energy, and build a smart energy future. We've been working with many industry and government partners for 6+ years on energy code adoption, energy code training, and compliance in Utah. And I've worked with Utah Clean Energy for about 10 years to advance smart energy efficiency programs and policies dealing with utility efficiency, energy codes, electric vehicles, clean energy financing, green jobs training, and the like. And I recently served as co-chair of the Buildings Committee for Governor Herbert's Energy Efficiency and Conservation Plan. We're lucky to have the Southwest Energy Efficiency Project, or SWEEP, supporting this webinar. SWEEP is a public interest organization promoting greater efficiency in Arizona, Colorado, New Mexico, Nevada, Utah, and Wyoming, and serves as the RIO, or the Regional Energy Efficiency Organization, for the Southwest U.S. SWEEP works on policy and programs that increase efficiency in the utility sector, the industrial and combined heat and power sectors, and the buildings and transportation sectors as well. SWEEP is headquartered in Colorado with staff in all Southwest states, and Utah Clean Energy has partnered with SWEEP since 2001, and we actually serve as SWEEP's representatives in the state of Utah. So before providing additional background on the Utah Residential Energy Code, we have a poll for participants to take. I'm going to put 3 questions up, one after the other, and I invite everybody to participate in the poll. We're going to start with a poll just to try to get a sense of the background of everybody participating in the webinar. So I'll leave this up for about 20 seconds or so and close it when the majority of participants have provided a response, and then we'll move on to the next question. A couple more percentage points coming in, and then we'll be close to 100. I'm going to go ahead and close the poll. And it looks like, let's see if I can share the results. It looks like we have, almost 40% of the participants are building contractors. Just about a third are building inspectors, a few architects and design professionals, a few HERS raters, and then a fair group, about 20% from other areas. Okay, I'm going to move on to the second poll question really quickly. This question is for building departments who are participating in the webinar. Just want to get a sense of, historically and up to current, how stringently you are able to enforce the current energy code given your staffing and resources and whatnot, just kind of a self-assessment of how well the energy code enforcement is happening. Looks like we have just over half. We'll wait for a few more percentage points to increase, and then we'll close that poll. Okay, I'm going to go ahead and close that. We have about 2/3 of participants responding, and looks like we have a pretty good blend of some amount of enforcement with about half of you representing that about average enforcement, and then almost 1/3 were really, or maybe a little over 1/5 were really prioritizing enforcement of the energy code. For the final poll, before we move on, for everybody, this question is designed to get a sense of how well, what is the current level of understanding about Utah's modified residential energy code, which is set to take effect on July 1st. And we'll leave that open for probably more like a minute or so. Okay, I'm going to go ahead and close this poll. It looks like we're speaking to an audience that will really benefit from this webinar. There's little to some understanding representing the majority, but almost half have little to no understanding, and so that's really the point of this webinar. It's to help bring this information to the folks who really need it. So on to the next, the rest of our webinar. Thanks for everybody for participating in those polls. Really quickly, I'm going to provide a brief background on the residential energy code in Utah. In March 2013, as many are aware, the Utah legislature passed House Bill 202, which adopted the complete 2012 energy code for commercial buildings, as well as a modified energy code for residential, which was based on the 2012, but in many ways is much more functionally closer to the 2006 IECC. The updated energy code is expected to reduce energy costs in new commercial buildings by about 18% and by about 10% in new homes on average. And the energy savings will also pump about $18 million into the state's economy over the next 10 years through reduced energy expenses in Utah's new, more efficient homes. House Bill 202 contained a contingent effective date that required a version of the U.S. Department of Energy's ResCheck software to be made available that incorporates the energy code amendments in House Bill 202. The ResCheck software was modified in mid-2013 and reviewed by numerous building and efficiency stakeholders between August and November of 2013. And again, just last week, the Uniform Building Code Commission voted to send this written certification to the legislature that House Bill 202 had been, the contingent effective date had been complied with, which triggered the July 1st effective date. So for today, the agenda includes an overview of the new energy code provisions in the Utah residential energy code. That'll be provided by Brent Ursenbach, and a detailed presentation of the new air leakage and duct testing requirements in the Utah energy code. And then, like I said before, we'll have time for questions and discussions at the close of the webinar. So today's presenters, we're lucky to be joined by Brent Ursenbach and Mitch Richardson, who will be providing really the content of the presentation for today's webinar. Brent Ursenbach is the Salt Lake County Energy and Mechanical Code Specialist and an ICC Combined Inspector. He has 33 years working in the HVAC field and now works as a code official. He's been working in this capacity for the past 8 years. Currently serves on the Utah chapter of the ICC Co-Change and Development Committee, president for the Rocky Mountain Gas Association Board of Directors, and is the chairman of the Utah Uniform Building Code Commission Mechanical Advisory Committee. He currently serves as a member of the ACCA Manual S Advisory Committee, working on updating the ACCA ANSI standard for residential HVAC equipment selection. He's actively involved in the legislative process, working on issues such as education and licensure of HVAC technicians and adoption of current energy conservation codes. And Brent has presented numerous seminars on energy, mechanical, fuel gas codes, as well as HVAC design principles. So we're glad to have Brent here. And our second presenter will be Mitch Richardson, who began his career in energy analysis as an energy analyst in 1996. That same year, he founded his energy inspection and building science company and has helped design, test, and inspect thousands of homes in Utah, Arizona, Colorado, and California. He's certified through ResNet and is a BPI trainer and proctor. Mitch regularly speaks at national conventions on building and marketing energy-efficient residential structures. He currently serves on several advisory committees for building codes, and helping builders meet their efficiency goals and code compliance in the most cost-effective manner is his passion. So without further ado, let's move on to the first other presenter, Brent Ursenbach. I'm going to give Brent control. Let's see. And unmute Brent. Brent, you should have control of the slides, as well as your line should be unmuted.
It is, I believe. Thanks, Kevin. It's great to be here, and I think most of you out there that know me know that I have a passion for this subject. I really feel as a code official I have a responsibility to serve the public, and serving the public is part of what I do by ensuring that the homes and the buildings they're purchasing or they're remodeling are energy efficient. I want to start with, I have a link, a website here right in the middle of the page here, right above my arrow, that tells you where you can go to get a copy of the amendments that were written and approved by the legislature, signed by the governor for the 2012 IECC. These are all residential amendments. There are no amendments to the commercial code. And so on July 1st, when we go to the 2012 IECC, it'll be on the commercial side completely as in the text of the code, and for the residential we do have some amendments, and we're going to talk about those right now. Kevin, I'm not seeming to have control of moving my slides, so can you
give it one more try? It should work now.
Well, I don't know if I did that or if you did that, Kevin, but the relationship between the IRC and the IECC, real quickly, during the 2012 code hearings, it was voted on and approved that Chapter 11 of the IRC would be identical to the residential requirements in the IECC. In previous versions of the code, that was not the case, and you would, for instance, not have the performance approach even listed in the IRC. And it created a lot of confusion and such, and so today, July 1st, the adopted code will be identical in the IRC and the IECC for residential construction. So that's an important step, and I think it's a good move that was made by the code development process, and that way we only have to carry the one book. If you're doing residential construction, you don't need to carry an IECC necessarily. As Kevin mentioned, codes are adopted by legislative process, and House Bill 310 year and a half ago adopted all the building codes except for the energy code, and we virtually adopted all the 2012 I codes that that we normally adopt. We don't adopt some codes, but we adopt, you know, the basic body of codes, and we adopted all of those, like I say, July 1st of 2013, except the energy code. They have to go through Business and Labor Committee, and it's the Building Codes Commission makes recommendations. We go through this whole process. We don't need to spend a lot of time there. It's not an automatic adoption. It does have to go through the legislative process. And that's an important thing that we remember. Several advisory committees study each code and make recommendations to the Building Codes Commission. They make the recommendation to the Interim Business and Labor Committee. Then it goes to the legislature and then to the governor's desk. As I mentioned, we did not adopt the energy code as part of the I codes that were adopted a year ago, and the reason is that the energy code was a separate bill, House Bill 202, and as Kevin mentioned, this bill passed. However, it had a clause at the end that it would not go into effect until a new res check that fit all of the state amendments was reviewed and found to meet the requirements of the code. So that's where we're at today. Generally, the entire state must follow all the same codes, with some exceptions for local amendments, which require legislative approval. And those things typically are adjusted roof snow load requirements. We also have some fire sprinkler requirements in hazardous wildland areas. And again, these all have to go through the legislative process. The format of the IECC is a little different for 2012. Those of you that are familiar with the 2006 or 2009 IECC will remember that we had Chapter 1 was the administrative section, 2 the definitions, 3 the general requirements, 4 was residential energy, and 5 was commercial energy, with Chapter 6 the reference standards. As part of the process of making the residential the same in the IRC, the codes were broken apart into simply 2 separate codes in the IECC. So you start with 5 chapters that are commercial, and then you start over with another 5 chapters that are residential. Reviewing real quick, and I am going to review energy code questions that I get all the time a little bit, so I'm not just going to talk about the changes, but I am going to do a brief overview of the energy code for residential construction and those things that I see common problems with. A residential building, according to the IECC, is a 1- and 2-family dwelling, townhouse of any size, and R2, 3, and 4 of 3 stories or less. So a 3-story apartment building is built out of the IBC, but it is not a commercial building according to the IECC requirements. So that is a residential building until you go over 4 stories, or all R1s are commercial buildings. This applies to additions, alterations, renovations, and repairs also. This is not a change, but historic buildings do not have to meet the requirements of the energy code, and existing buildings that you're not doing anything to, you're not remodeling or anything, you don't have to meet the code, and very low energy buildings, which are basically 1 watt per square foot or less. To put that in perspective, a 1,500 square foot building could have no more than a 1,500 watt little plug-in heater as the heat source, and so it's very difficult to get a building that has that small of a heat source. So that's very rarely is that option used or available. Too far. Real quick, this is a big question I get all the time. Rooms and additions. Typically, when you have a addition like shown in this diagram, it's simplest just to treat that room addition as a separate building. So that would mean that you do a res check or you meet the prescriptive code for this little section here. You do not input the wall where I have my arrow, because that is a wall between two conditioned spaces, so that is not part of a thermal envelope. Oftentimes sometimes that might not be the best solution, but that's typically the best way to go. The existing part of the building is typically not even close to meeting the code, and so you do not need to go there unless you're making changes in that part of the building. In alterations, repairs and all those things, if you're putting storm windows in, you don't have to meet the code. If you're doing a glass-only replacement, you don't have to meet the code. But if you are changing the whole window, sash, frame, all of that, then that new window needs to meet the energy code. If you're doing nothing else but changing windows, those windows need to comply. If you expose a cavity, it needs to comply. If you expose a roof, it needs to comply. The roof thing, that's going to need to be a building official's call sometimes, but typically if you expose a flat roof and we have no insulation, it's sure a great time to add some. If you turn an unconditioned or non-conditioned space into conditioned space, then you need to bring that envelope into compliance, and that can be difficult. We encounter that regularly in my jurisdiction. Someone's enclosing a carport or converting a garage into a heated room. You need to get that insulation and the windows brought up to code. The IECC is really kind of two parts to it. There's some climate-specific requirements. They vary depending on how cold or how hot you get. And it's roofs, walls that are above grade foundations, which include basements, slabs, and crawl spaces. Then we have our fenestration, our skylights, windows, and doors. And then in our warmer climates, we have a solar heat gain coefficient that we're concerned with. And then everywhere, no matter where you are, no matter what method of compliance you're using, you need to meet these mandatory requirements of infiltration, duct, insulation, sealing, sometimes testing HVAC controls, and so on. Climate zones have not changed. They're the same as they were in previous codes. We have 3 climate zones in Utah. The red text are things that are changes in the residential code. As I mentioned, we kind of focus on the building envelope with those issues that I've talked about. With the 2012 code as amended, there is blower door testing that might be an option, or it is an option, to show compliance with the air sealing. And Mitch is going to go into detail on that. With our ducts and air handlers and everything, there's possibly a testing requirement there if you have duct outside the thermal envelope. And again, that's Mitch's part of this presentation. Very little on the actual heating and air conditioning, water heating equipment, because that's set by federal standard. There's no appliance requirements for ranges and fridges, and all the lighting requirements were deleted by amendment. You have 3 compliance methods. Those of you that are familiar with previous codes know that you can meet prescriptive code. You just meet the table, and you don't have to do anything else. If you want to do a trade-off, then you would use something like ResCheck or a similar UA, area-weighted calculation, to meet it. And then we have energy analysis, or the performance approach. And Mitch is involved in that process quite a bit in his line of work. And that's where you show that the building you propose to build will not use any more energy than a prescriptive compliant building. There is a state amendment that allows you in ResCheck to still use an equipment trade-off. So you can have a poor wall assembly compared to the prescriptive table, but you can meet the code by having a high efficiency air conditioner or furnace. I took a picture of the screen. Kevin mentioned that we have a new ResCheck that's written specifically for the Utah amendments. And when you go to ResCheck and you click on the code button up here, this little drop down will come in, and we have right there Utah 2012. So for any projects that are starting after July 1st, if you're going to use ResCheck as your compliance method, it will need to be Utah 2012 code. we must be aware of the complete thermal envelope. I often see a res check or a load calculation that a component's been left out. We need to complete the whole thermal envelope and make sure we're accounting for every one of those components. You can't leave this floor out. You can't leave your basement walls out. Now really, we don't put anything in the energy code for this part of the floor if it's below grade, but we do consider that in the load calculation. This is the 2012 prescriptive table, and if you notice here, for example, climate zone 5, which is Salt Lake and Utah County and the greatest portion of the state, windows have a 0.32 U factor. If we go across, 49 in an attic, R20 in a wall, and so on. We have some changes here where some of these things are higher than they were in the 2006, but by state amendment, we have virtually gone back to, in most cases, there's just a couple of things that are different, but these values in red are basically the 2006 prescriptive table requirements. So there's really not a lot of change there. It's 0.35 windows, 38 in an attic in climate zone 5, R19 in the wall, and so on. The one change is I think we have a change in the walls in St. George right here, and I think that's really the biggest change, or the only change in that table. And then we have a prescriptive method down here in footnote J for log homes. If it's a 5-inch or greater log, they can comply prescriptively with 0.31 windows and a 90% furnace. By fenestration, we're talking doors and windows, anything that you put in a hole in a wall or a roof. NFRC rating for manufactured, we don't have a limit on area. I get calls on all this all the time. If you have a house that's 80% glass, you can use the prescriptive path for that. There is no limit on how much glass you can have. If you do not use prescriptive, you're going to have some challenges meeting the energy code. And then we have an exemption, 15 square feet of glazing in a dwelling unit. Doesn't have to comply, so if you have a stained glass window you want to put as a transom above the door, you can do that. And it doesn't have to have a sticker. It doesn't have to be double glass. You're allowed 15 square feet. And the same thing goes for one single door. The state amendment allows this exemption for any method or path of compliance that you use, where the code says it's prescriptive only. There is a limit, and this has always been there. Your windows, any of the windows that have to show compliance, so I'm saying any of the windows other than that 15 square feet, have a maximum of 0.48. You can't put 5/8 windows in and then try to trade them off with something else. There is a hard limit of 0.48 on windows. The ceiling will either be an assembly like a sit panel or a rafter or a flat roof with continuous insulation on top, or you could have insulation between framing members. Insulation needs to be labeled and identified. This is not new stuff, so I'm just going to move on. Insulation is not considered continuous. Often I see someone say, oh, well, it's continuous insulation over here where it's blown over the top of the bottom core of a truss. That is not considered continuous. That is cavity insulation for the full depth of that attic. Note that this is the less poor design for trusses. We have very thin insulation here, and so we have issues with and problems with that. Because of that, if you can go full depth out over your wall, and like climate zone 5 where R38 is required, you can actually drop the insulation down to R30 for the entire attic for that. That was a prescriptive only allowance, but by state amendment you can use that on any approach on energy compliance. If you have 500 square feet or 20% of the total house, you can go R30 instead of R38 for a small raptor area over a master bedroom or a bonus room. But you need to remember, and this isn't in the energy code, but it's in the IRC, if you have a rafter or an unventilated space, you need to have some air impermeable insulation for that roof system to prevent condensation. And so in climate zone 5, your first R20 of insulation up against the bottom side of the sheathing, if it's a roof rafter, has to be closed cell foam insulation, air impermeable insulation, and then the remaining R18 can be whatever you want. This is something that's being missed. It's been in the code, I think, for 2 codes now. It was in the 9 and it's now still in the 12. So this is something you need to be aware of. If you have some questions, give me a holler on that and we can talk about it. New in the 2012 code, well, it's actually in the 2009 residential, but we didn't adopt that. Remains in the 12 is attic accesses have to have the insulation secured to the panel so it doesn't fall off, and it has to be gasketed all the way around. That is a mandatory requirement. When we're talking about walls, we should not forget rim joists. So it needs to really go all the way down. If our insulation path is coming all the way down here, we need to make sure our rim joist areas are taken care of. We can't leave holes in there. Wood frame walls, these are the 12 values. It's actually amended down to 19. When you see 13 plus 5, that's 13 cavity insulation and R5 continuous over the outside surface. Quick note on steel studs. Steel studs create a very easy path for energy to flow, the thermal bridging that takes place. If you use steel studs on an exterior wall to equal an R13 wall, you'd have to take R13 and put at least 4.2 R value continuous on it. If it's an R19 wall, 2.1 has to go continuous over the face of it, or so on. Very important. If it's a basement, you're finishing a basement and you want to use steel studs, you would need to put virtually an inch of foam on the back side of the studs and then frame the steel studs and then insulate the cavities. As this little box tells you, R13's cavity and 4.2 is continuous. Mass walls, those walls that have a lot of mass to them. The table, it assumes these are all above grade walls. That's not a change, and you'll notice that the mass wall insulation values are significantly less than they are for a regular frame wall. The first value is the total R value if at least half the insulation is on the exterior. If the majority of the insulation is on the interior, you have to have more insulation. Floors, we need to make sure we consider floors and make sure we take care of. This is a floor. This is actually a ceiling, as this is a ceiling. Floors over unconditioned spaces are 30 in climate zone 5, 30 in climate zone 6, and 19 in climate zone 3. There is an exception that if your framing member isn't big enough for 30, you can go down as low as R19. So you could use a 2x6 and put R19 in it if it's a short span. Crawl spaces, there's a couple of methods of doing this. You either treat it as an insulated floor with R30 in most of our climate zones, 19 in our St. George area, or we can not vent the crawl space and we can insulate the wall here and put a taped and sealed vapor barrier on the floor. And the code goes into very specific detail on how this vapor barrier has to be sealed and taken care of tightly and make sure that insulation goes all the way up. Definition, we'll just review this real quick. If this wall is 50%, is more than 50% below grade, then it's considered a basement wall and meets the basement wall requirements. This wall here looks like it's more than 50% above grade, so that would be considered an above grade wall, so you'd insulate to that requirement, and of course this is an above grade wall. And there's our insulation requirements, as you see in climate zone 5, 15 continuous, 19 cavity. Actually, those have been amended back to the 10 and 13 of the 2006 level. Slab edge insulation is always a challenge, and it hasn't changed, but it's simply one of the least enforced, and it does need to be addressed. There's a significant amount of heat loss from slabs into foundations to outside if you do not have a thermal break here. There's the U factor tables that you can use instead of the R value tables. If you are using these U factor tables, I just want to point out footnote A says non-fenestration U factor shall be obtained from measurement, calculation, or other approved source. You need to have a calculation if you're using this table that accounts for all the framing members, all the components of that wall. It is not simply taking the reciprocal of the R value of the cavity insulation. This needs to be supported by calculation. And it is amended too. Sunrooms, I think we miss the boat on these quite often. A sunroom, if we have a sunroom added onto a house and we are not conditioning it, we don't have to worry about it. Nothing takes place. It's not a conditioned space, so you don't have to comply with the code. However, if you are putting a little unit in there to condition that sunroom at times, then you need to really treat it as a little standalone room. You still need to insulate this wall for the same requirements of the home, so that meets the full requirements of the code. The sunroom, however, has reduced requirements. For instance, the ceiling is an R24. Windows are 0.45. Simulated performance approach, that's the third alternative. It's done with software. I'm not going to spend any time on that. I think Mitch might spend a few minutes on that. And if you have questions, feel free to get a hold of us on that. If you do Energy Star, that's often the method that's used to show compliance. Mandatory requirements that apply everywhere, and this is the area that Mitch is really going to focus. And so I'm just going to brush on through that and not spend too much time there, but a big part of every home, we have heat loss through the components, but we also have heat loss or heat gain by air leaking through those assemblies. And we know about all those things that you need or can do to seal. Just want to make the point that a typical home built today leaks its entire volume of air every 3 hours or 8 times a day. You are reheating or cooling the entire volume of air in the house because it was lost outside and replaced with air from outside at whatever temperature it is out there. The air leakage, and this is Mitch's area, so I'm just going to mention that the code 2012 says 5 air changes per hour for climate zones 1 and 2. 3 air changes per hour for climate zones 3 through 8. By state amendment, everything's 5 air changes per hour. Let me back up. You either test the house or you field verify that the envelope's tight, and that's an option similar to what was in the 2009 code. You don't have to test the house, but it is an option, and it might be the best option. If you do not test the house, we have a whole table that's going to be part of Mitch's presentation on how you have to make sure that that is sealed and it's insulated correctly. Duct sealing, another area Mitch is going to spend his time on. Basically, there's The sealing requirement has been around for a long time, and ducts do need to be sealed. And if ducts are outside the conditioned space, then they need to be tested and make sure they're tight. An amendment changes it from 4 CFM per 100 square feet of conditioned floor area from 4, and these red numbers are all state amended values. So there is a testing requirement for duct if it's outside the envelope, but it has been relaxed a little bit from what's in the 2012. Building cavities. The 2012 code says basically you can't use framing cavities as a duct or a plenum. The state amendment, and I was there while this was being discussed, the intent of the state amendment was to allow panning still, that you could pan a joist. The challenge is how do you get it sealed. This is something that we probably are going to clarify this year, because all the state amendment did is cross the word or plenums off, and so there is some confusion. Framing cavities cannot be used as ducts or plenums. Well, what's the difference between a duct and a plenum? Is a floor joist a plenum or a duct? And I know the intent was that you can still use those framing cavities, and they were being called plenums. Obviously, if you're putting a furnace on a box, a big frame box underneath it that collects returns from all over, that would be considered a plenum, and that's not an option any longer. However, the intent of the amendment was that you can still use stud spaces and floor joists for a return path. Snowmelt systems. This is new to the 2009 code. Many of you code officials out there have told me I'm not going to enforce the energy code because we waste so much energy in our area because with snowmelt systems. And snowmelt systems do consume a lot of energy, but they really consume a lot and waste a lot when they do not have automatic controls. So the code now requires that if someone puts in a snowmelt system, they must put in controls that sense slab temperature, air temperature, and moisture, so the system does not run unless all the conditions are there for creating ice. This can save a huge amount of energy because there were snowmelt systems put in that people just turned them on at night if they thought it was going to snow, so they ran all night long. And if it didn't snow, it was all wasted. It was running hours and hours before it did snow, and then it ran hours after it needed to. And so this is a big improvement on snowmelt systems. There's a number of controls, and they work very, very well. And simply stated, you cannot have manual switches or timers on your snowmelt systems. You have to have that little sensor that's poured into the driveway to automatically operate that system. This one was a long time coming. You can no longer have a continuous burning pilot in a pool boiler or a hot tub boiler. And this is the first time that's been in the code. This one should have been in the code a long time ago. It has to have an intermittent pilot light on it. Then there are requirements on timers and such so that pumps just don't run continuously when they're not needed, with an exception for areas that you have to run 24 hours anyway. And then the last final item I think we have here is lighting equipment. Over the last 6-7 years, there was a lot of debate on what portion of the energy code or the energy savings realized from the code was due to lighting. And then there was a lot of debate that, okay, we put in CFL or LED lights for final inspection, then someone takes them out. Well, it's something that we're not going to be able to regulate or control, so the state amendment simply just took the lighting out. We're not going to worry about it. People generally, the majority, are updating and upgrading their lighting in their existing and their new homes, and I think the public's taking care of this one for the most part, and so we took it completely out of the code. I mentioned just a couple of last comments on Utah. Effective date is, as we said, July 1st, just less than 2 weeks away, 2014. There is a new res check specifically for our code. We have a prescriptive requirement for logs, and we have a new definition for conditioned space that's put in the code by amendment. And what that requirement says is you can indirectly condition a space and consider it a conditioned space. What this means is if you choose to blanket the walls on a basement, putting the whole entire basement inside the thermal envelope, that's great. You don't have to insulate ductwork down there. Everything's inside the thermal envelope. You do not have to put supplies and returns down there or directly heat that space. You can indirectly condition that space just by the heat radiating off the ductwork or the heat transferring through the floor above down into that space. This is a change that's going to occur in the 2015 code across the board, but we decided there was enough questions on this that we would put it in. I submitted it as an amendment for the state code to eliminate the confusion and the double insulating that was being required in some areas. That's my portion of the presentation. I appreciate the opportunity to present this, and I welcome your comments and questions. I spend a lot of my day addressing energy and mechanical code questions. Feel free to get a hold of me. Let me assure you that my phone is not the best way to get a hold of me. You're welcome to try, but it is best to use one of those 2 email addresses, and I'll try to get back to you as quick as I can. Thank you.
Thank you, Brent, for the very, very thorough overview of the changes, kind of background on the codes and key issues in the codes and some of the key changes. Again, if you have questions for Brent, please type your questions into the question area of the sidebar. And before we move on to our next presenter, we have 2 other poll questions. So, and these deal with the presentation that's just coming up. So, the first poll is, I really just want to get a sense of who has direct experience conducting or witnessing air leakage or blower door tests. Get a sense how new this is to participants, or not new, as the case may be. Looks like we're about 75%, 76% of you have voted. Looks like I'm going to close the poll in just a moment. So get your answers in if you want to vote or if you want to share your experience. Okay, close the poll. And we have the results are showing that almost 60% have had some experience either conducting or witnessing an air leakage or blower door test, and just over 40% have not. I'm going to move to the second poll in this section before Mitch gets started. And it's the same question, but just with respect to a duct tightness test. So we'll leave it open for 45 seconds or so. Okay, looks like we have almost 80%. If we want to have a few more people submit their experience, I'll close the poll in just a moment. Okay, I'm going to close the poll now, and it looks like there are less participants who have had any kind of experience, direct or kind of experience witnessing a duct tightness test. 55% of you have not, and 45% of you have. So thanks for participating in that poll as well. So I'm going to turn the time over to Mitch Richardson, who will give us a detailed overview of the new air leakage and duct testing requirements.
Fantastic. Welcome, everybody. We're going to talk about what it takes to get the homes tight, different ways that you can comply with the code, and some reasons why we're doing it. And then, Kevin, do you just want to slide? Okay. All right. Well, we all know that with the new code, the homes must be more airtight. There's two ways to do this. There's either a complete fairly stringent air sealing or air barrier checklist to do, which for many of you will also require that there's going to be some sort of photo documentation required, because of just otherwise you'd have to go out to verify these things 4, 5, 6 times during the course of construction. So there's that method, or you can pass a blower door test, with a qualified third-party tester, so to speak. Okay. Here is we're going to talk about the checklist first. What it would take to comply with that. I'm going to refer to it as the prescriptive air sealing checklist, though technically it's the air barrier and installation checklist. But air sealing checklist is easier to say. We're just going to touch mostly on some of the more difficult or costly requirements to comply with this method, and then we're going to follow up with and if you're going to do this method, probably a follow-up class would be warranted on for those who intend to meet compliance via this method, because there's a lot to go through. But next slide. If you look to the blue arrows, we're going to talk about the air barrier and thermal barrier and the rim joists. This is probably the most costly and or difficult thing to pass with this checklist. If you look at the photo that has the green line on it, that's my green laser line. Typically what's done right now is just you take a R13, R19 bat if you're lucky, and they just stuff it up in that rim joist area. With this checklist method, this is a complete fail. It does not enclose the insulation on all 6 sides. It does not provide any sort of air barrier or air sealing to that using this method. And then I have a different photo of a method that would pass, and that's closed cell foam that obviously would do the air sealing and air barrier for it. Then they might add additional insulation to the backside of that. And that would be a passing method. There's many ways to air seal or air barrier that rim joist: caulking, mastic, spray foam, spray latex. None are easy or cheap. There's also thermal form. You could use rigid insulation, but this point alone might make the third-party blower door test, or using the performance method, the more cost-effective option, because this is a fairly costly or involved thing to pass on this checklist. Next slide. In the ceiling or attic, the attic knee walls must have a full air barrier on the attic side sealed on all 6 sides, and the knee wall must be full depth. There's no more of this business where you're trying to squeeze an R19 bat into 2x4 attic truss. This photo we're looking at here is an attic knee wall that borders into conditioned space. And see all the discoloration along where that door is. That's just a great example of how insulation that doesn't have an air barrier on all 6 sides. Insulation without an air barrier is just an air filter. That's just dirt and dust from of air that just freely passes through that insulation along that place. Let's get next slide. So here we see the air barrier is done correctly, but they've squeezed an R19 bat into a 2x4 cavity, and which would give you more along the lines of an R15, which means that this particular installation would fail the current this new code. Next slide. Here is thermal image of an attic knee wall that had an air barrier placed improperly. So the air barrier was done well along the attic side, but it did not come up over the top of the insulation. And you can just see how much, this was on an 80-degree day. So it wasn't even an excessively hot day. You can see how much heat was leaking into that home just due to the fact that the air barrier was not wrapped around the top of that attic knee wall. Next slide. The ceiling or the attic access hatches must have insulation attached to the backside. Emphasis on attached. It's got to be glued. It's got to be screwed something, and the hatch must have the gasket. And the gasket would obviously go between the lid, and the lip. Next slide. So this is a brand new house, again, like an 80-degree day, and you can just see it has, the insulation was not attached to the backside. It was there. There was just a free-floating piece of insulation on the back of this attic access hatch that had no gasket, and you can just see how much heat was leaking into this home. So much that there's a huge reflection off the wall. So it's an important and great addition to this little checklist. Next slide. Well, this photo is a little bit small, but on subfloor areas, you have to fill the entire subfloor cavity. Frequently, an R30 bat will do this, but sometimes it won't. If it won't fill the entire cavity to the degree that it will maintain contact with the subfloor, you're going to have to use props, typically 1 foot 18 inches. It just depends on what the manufacturer has designated. Wire rods you'll frequently see, but they're very non-compliant as they twist and sag and in no way will maintain permanent contact with subfloor. And when those, and just for those of you who don't know, when the insulation sags and there's a gap between the subfloor and the insulation, it's the same as if that insulation wasn't there at all. If it's a 1/4 inch gap or more, it might as well not have been there. It was just a waste of money. Next slide. Garage separation. So here we're looking at 2 pictures of areas separation between. So there's garage on the other side. Obviously, a lot of toxic chemicals are stored in garages. Combustion things happening in garages. The new code with this checklist would require that there be an actual air dam, in those joist areas between the garage, and the living space. Sometimes this can be done with drywall. It can be done with a redesign of the truss, the floor trusses, by talking with the framer, that kind of stuff. If it's discussed with the framer and the designer ahead of time, it can be fairly easy to meet. But if you have to go in and cut in, like we see on the right-hand side there, the thermal pan, that can get kind of expensive and time-consuming to meet. But it is required as part of this prescriptive checklist. Next slide. IC cans. So IC is insulation contact airtight rated cans. So ICAT. ICAT rated cans must be installed correctly, or sealed air boxes must be installed over them, as shown in this picture. Please note that the electrician, good old Sparky, has to install the cans with the gasket on the finished trim piece. That gasket is almost always missed. So it's pretty easy to check. Just flip your finger up there, pull down the trim piece a little bit, and check that gasket is there. Because when we go out to inspect it, it's almost always missed. Next slide. Okay. Plumbing and wiring, and just generally how you install bat insulation. Bat insulation must have no gaps, voids, or compressions, no inset stapling. Basically, it's got to fit in just like it was blown in. Here we see a pretty poor example of how it can be done. Just see how much of the stud that you can see on the side there. This is pretty poor. It's you get a lot of convective loops, and the air will just move freely inside those air cavities, and it will reduce the effectiveness of that insulation by minimum 30% and up to 80%. So, and I've seen it, and honestly, on that first bay there, they might as well not have put anything in. Next slide. So here we see where they just kind of stuff the bat behind the pipe. What should be done is they should cut along. They can stuff it behind that pipe, then they need to cut it and fluff it back out to fill that entire cavity. Because again, if you don't do that, it's like you might as well not have put anything in that bay. It's the same thing for wiring. Next slide. So here is an example of a void. So same deal here. You know, that void along there will allow air to pass freely between the outside. You know, say in the wintertime, air is going to get cooled down. It's going to pass through that void. It's going to come on the warm side, and the air is just going to freely cycle through. And again, in that particular bay, they might as well not have put anything in. Okay, shower tubs on exterior walls. So showers and tubs on exterior walls, for those of you who are familiar with the Energy Star requirements, this has been a requirement for a while. It's pretty easy to do. It just requires some coordination ahead of time that whoever's installing the tubs, you know, has to put up an air, you know, the insulation and the air barrier before the tub or shower gets installed. You know, up top we see a poor example of how this can be done, and down below we see it done well. This isn't a tough requirement, just requires some coordination on behalf of the builder. Next. Electrical boxes, electrical penetration. So when you've got plugs and switches on exterior walls, we're just going to need to have the requirement on this checklist would be you're going to have to caulk at the wire penetrations as shown in this little photo. So any of those little penetrations are going to need to hit some caulk or some foam. And then, you know, a gasket on the outside of that, you know, of the trim piece when it gets installed. Next slide. HVAC register boxes. So this goes for supplies and returns. You know, up top we see how the typical, you know, boot comes through the drywall. You can see all the gaps and voids that are around that, you know, that you typically see between the drywall and the boot. So you either have to use some foil tape, some mastic, or like in that bottom photo, there's like foam tape that they can use, and then they install the register over the top of that and screw it down. All those ways are really great ways to seal up those gaps. Probably the best method is the one on the bottom there. Does a great job, and we've noticed in our testing that each of these boots, when they're not sealed, will lose you know 10 CFM per boot off of the entire system. And there's a lot of pressure at these boots right at the register, and a lot of expensive air just gets blown out right into the walls or into the ceiling because of, you know, they're not sealed. There's all those gaps. Next. So fireplaces are going to need, you know, after you put the insulation behind them, you're also going to have to put up the air barrier. This is a good example of an air barrier put up. My finger there is showing, however, that air barrier got ripped, so that will need to be repaired. But that's the kind of thing that you'd need to put up as an air barrier. Also acceptable, if not more preferable, is some of that the foil house wrap. Tyvek will also work, but something needs to go in. Next slide. So homes need to be more airtight. There's two ways to do it. You can either do that whole huge checklist, which can be very expensive, and probably going to need photo documentation, or pass a blower door test. And if you're going to choose the blower door test method, Energy Tester can tell you, you know, which of the improvements that you would need to do to get you to pass the test, you know, without having to do the huge list. So let's talk a little bit about doing a blower door. Here on this house, this is we did a few weeks ago. Here we see a blower door mounted in it. This is about an 80-degree day. Next. So a blower door. What we're doing is we're depressurizing the house by 50 Pascal, which is about 0.2 inches of water column. It's the equivalent of a 20-mile-per-hour wind on the house. So we'll depressurize, and then we'll note the CFM of air leakage, or of air required to depressurize by that amount, and that CFM number is the leakage rate. Next. So the ACH calculation, as you remember, the limit would be 5 ACH per hour. So you just take the finished square foot times the ceiling height, you know, roughly. It gives you the volume. If you want to get, obviously if you've got vaulted ceilings, coffered ceilings, that kind of stuff, it's a little bit more complicated, but that's the basic formula. Take that volume, times it by 5, divide it by 60, and that's the max CFM allowed to pass for that home. In other words, the ACH is how many times all the air in a home will leak out in 1 hour when it's depressurized to 50 Pascal. Next slide. Air leakage, is it a big deal? Well, yes. A third of your expensively conditioned air is just blowing out all the homes in your house every hour. And this is even on current new homes. If there's a pressure difference, like if you've got a 2-story home, there's a stack effect that gives you pressure difference. If there's a wind, there's a pressure difference. If there's a temperature difference between outside and inside, you've got leaks. Or if you have an unbalanced duct system or a leaky duct system, you will have leaks. Next. Here we see yours truly performing a blower door test on that home. We calibrate to do a test properly. You calibrate it with the fan closed. Then you open it up and start depressurizing the house. It's important that the gauges get set up correctly, that you've got the red hose going to the fan, that you've got the green hose going outside, and that the other 2 taps are left open. And that it's pressurized, roughly between, this DG700 is most likely what any of you will see out in the field here in Utah. It's the most common equipment fielded here. If you see, it automatically calibrates to, adjust for what the exact CFM of depressurization is. But usually you're looking for a number between, 45 and 55 Pascal. Ideally hitting as close to 50 as you can. And then that number on the right-hand side, the 1353, is the CFM number that you would write down to determine whether or not this home passed or failed. Next slide. That's just where the hoses go. Please note that sometimes if it's a windy day, the best place to mount the blower door would be in the garage if it's a, just to eliminate buffeting on the gauges. Next. Okay, why are we doing a blower test? Our home's really that leaky. This is a fun experiment we did on this test. This is my assistant Troy. He's blowing fog, outside the building as we're depressurizing, just to see kind of what would happen if we could get an example of leakage into the home. That's just regular disco fog. Next. And if you can tell, immediately it started to become very hazy, down in the basement, just to show you how leaky those rim joists can be. Next slide. Here with my laser light, you can just see all those swirls is that disco fog leaking into the building. And again, this is the equivalent of a 20 mile per hour wind. You'd see roughly the equivalent, in a 2 or 3 story house, just with the pressure. Next slide. Again, those swirls are that fog coming in, penetrating into the house. Next. More examples of that fog penetrating in. And here we switch to thermal camera, no fog. You could just quickly see how much air is leaking in through those rim joists. The the whiter and yellower the colors, the warmer it is. Next slide. Again, on this slide, if you can see, where's that mouse? If you can see right here, you can see the trails of the air leaking across and warming up the surface of the subfloor. Next slide. And here's a great example of leaking into a finished area. This is the sunny side of the wall, and you see those trails of that warm air leaking into the house underneath that wall and heating up the floor. Next slide. Again, same story here. Plus here we have a chase up for that allowed additional leakage into that wall. So after we complete the blower door or duct blaster test, our firm, what we do is we post a report on the furnaces. In addition to taking our photographs and photo documentation. And this is an example of what we put together to prove compliance with the duct test, where we write down and this is the bare minimum required to prove compliance with a duct test. If your local code branch wants more information, obviously they have every right to demand that. But this is to be the basics. So a blower door with the performance method compliance is typically the most cost-effective way to prove compliance. You may have to do, as a builder may have to do additional air sealing measures over what they do now, but they would not have to do all of the measures on that large checklist. And the energy inspector will help determine, which measures would be the most cost-effective to meet compliance. Next slide. Who can provide air leakage tests? Section 402, following parties, and this is for the Utah Code, it was amended to say the following parties shall be approved to conduct testing: parties certified by BPI or ResNet, or licensed contractors who have completed training provided by blower door test equipment manufacturers or other comparable training. So currently the blower door test equipment manufacturers do not provide training, so there's no comparable things to that. So pretty much as written right now, what we're looking for is someone who is BPI or ResNet certified can provide air leakage testing. And the same for duct testing. Next slide. Okay, let's talk about ducts. There's two triggers for a duct tightness test in Utah's 12 code. Number one is if a furnace is outside conditioned space, if the furnace is in the attic, the crawl space, or the garage, for example. Or the other trigger is if 50% of the duct length for a system is outside conditioned space. So ducts running through the attic or ducts running through the crawl space, if 50% of that length is outside, then the duct test is required. Next. All right, here's an example of a duct blaster hooked up to a furnace system. There's two different ways you can do this. You can hook it up directly to the furnace where the fan is, as shown here. The other method is you can hook it up to the largest the largest air return in the system. So for example, if the air return if the furnace is in the attic, sometimes the easiest way to do it is to hook up the duct blaster to the air return instead of to the furnace handler directly. Either method is completely compliant and indistinguishable from the other. It's just which is easier. Next. Here's how they're hooked up. The red hose has to go to the fan. White hose has to go to a pressure probe in the air return system. Typically, it's within arm's length is where you'd punch a hole in the system to put that probe. Next slide. Again, it's just important that the pressure gauge is set up correctly to the right, equipment, and the right ring or opening on that fan is set correctly. Otherwise, it will skew the results wildly. Next slide. So the method of doing a system or a duct system test is you have to seal off all the returns and you have to seal off all the supplies. There's two ways you can do it. Our firm uses a mixture of either taping it or we use these closed cell foam blocks. So you pull off the guard and you put in the block. Next slide. As shown there is completely sealed off that little return or that little supply. Next. Usually it's easier to tape over the returns. One caution in taping over returns and supplies is you don't want to peel off new paint. So make sure that the kind of tape that you are using won't peel off the paint. Like regular white masking tape, you'll sometimes peel off paint, especially if it's like that sponge painted or fancy stuff. So next. Why duct testing? Well, first off, visual inspections just don't work. There's just too much ways you can hide stuff. I'm going to show you some examples of this house that we tested here just the other day. This HVAC crew knew we were going to test this home, yet it was 38% leaky. So in other words, 38% of the air was going to places it was not designed to go. And remember that the limit for this, this new standard is 10%. And 10% is not a stringent requirement. Energy Star is, more along the lines of 6%. So they knew we were coming to test this house, and yet 38% leaky. Leaks means that some rooms are going to be too cold, some are going to be too hot, there's going to be lots of wasted energy, fights over the thermostats, comfort problems, etc. It's a big mess. So if a home doesn't pass, typically we'll pump disco fog into the duct system to find the leaks and to make sure that we set up our tests correctly. And just for an example, after 3 minutes of pumping fog into this supposedly sealed system that by the way had already passed the city inspection, this is what the basement looked like. It was completely obscured with fog. Next slide. So where are those leaks typical? Air return pans are not sealed. Notice that first picture against the subfloor there was not sealed. I noticed there down at the bottom, the corners were not sealed. Next slide. So that very same return that we were just looking at, follow the green line to the rim joist. This air return is going to pull outside air right through the rim joist all day long, even if that basement gets finished. Next slide. Again, here we see the fog coming through my laser light. And this is a huge leak through the return system, and lots of fog coming through there. Next. Here's just some more examples of air return pans that are not sealed and will pull outside air right through rim joist areas. Next. Sparky loves to make holes in the return ducts. Frequently, sometimes we'll have a system that passes, and then Sparky comes in and has to fix something, and he makes holes in our systems when they're in those eye joists. So it's something to keep an eye on. Next. Factory seams. They're small. They're like a pencil crack, but they're very, very long. That pencil, line crack is 600, 700, 1,000 feet long. That's scribble that out on a piece of paper, and it adds up to a really big leak. Next. Here's a fog leaking out of a factory seam. Now, note that it's amended that these long factory seams are not required to be sealed, but if you want to tighten up a system, it's a great way to do it. Next. Elbows must be sealed on the side you can't see from the ground. I know inspectors have always looked at the part you can see, but the side you can't see doesn't get sealed. That won't do anywhere. Next slide. All elbow seams must be sealed in the new code. So notice where my elbows are. It's not just the joints anymore, but all of those adjustable elbow seams must be sealed. It's spelled out specifically that they must. And they do leak a lot, as we could see in that laser light showing the slide or two ago. Next slide. Again, so when we get done with a duct test or a blower door test, we typically post our stuff right there on the furnace. Next. And this is what we typically write down for it. So we write down the observed leakage, the square footage, the calculation required, and whether or not it passed or failed, who did the test, and our contact information. Leakage as a percentage of square foot, etc. Just the basics to prove compliance, along with our photo documentation. Next slide. So why duct testing? Visual inspection isn't enough. If HVAC, if homes where HVAC crews knew their ducts were going to get tested but were failing miserable, but visually look fine. Imagine how bad homes are where they know there's not going to be a test. Next. So when duct testing, if the furnace is outside conditioned space, you got to test. If 50% of the length is outside, you got to test. Next slide. Generally, so that's what we had to say about the ducts. So there's 3 ways to pass the 2012 code. There's a checklist only method, which is prescriptive, also referred to as prescriptive. There's the trade-off method, which is a mixture of the checklists or the prescriptive checklists and the total UA, which allows for trade-offs between, lesser wall insulation but a better furnace, for example. And then there's a performance method, which allows, there's still some mandatory requirements, but everything else pretty much can be traded off. And the performance method requires the involvement of a third-party energy inspector, such as myself, or any of the other similar inspectors in town, where we do the following. Next slide. So performance method, or section 405, you have to use an energy rater. It involves extensive computer modeling. With most local raters will use REM rate. All res check will also work. And it will also require testing of the home, which a third-party rater performs. This method is the most flexible and is almost always the most cost-effective way to comply with code, and it's a very reliable way to meet the code, and shows that, you know, this home is tested to prove that it will come in at a less energy use rate than, you know, the typical prescriptive home would be. Next slide. Performance method is also useful for utility rebates and tax incentives. It's also useful for internal quality insurance for the builder and a reduction of liability for the builder. Most production and multifamily, excuse me, most production and multifamily builders use this method. You know, for example, Ivory, Richmond, Garbett, Wasatch, ICO, Castle Creek all use this method to prove compliance with code and to, you know, take advantage of those other you know, incentives. So my name is Mitch Richardson with Survey and Testing Services. Feel free to give me a call if you've got follow-up questions, or drop me an email, and I'd love to help you out.
Thank you very much, Mitch, for going into that level of detail on these new air leakage and duct testing requirements. I'm going to open up our questions so I can see them all. It looks like we've had quite a few questions come in over the course of the webinar so far. So, you know, why don't we just get started with a couple of these questions. Some of these look like they may be directed more to kind of a general code question, and some look like they might be directed specifically to air leakage and duct testing. The first question we have is whether or not an R15 cavity, I'm going to unmute Brent real fast, whether or not an R15 cavity and an R4 exterior foam would meet the code requirements in St. George.
Yes, that would be compliant. I'm not sure what they're using for R4 on the exterior. You know, it's typically a R5 for an inch of foam, but they might be a product or 3/4 of an inch or something. So in St. George, yeah, that would be okay. I would consider that compliant. Kevin, I'm not seeing the questions. I don't know if you're trying to make them visible to everybody, but
I don't think I have that ability, but I just have them open on my screen. Thanks. Second question, suspended slabs over the garage. Is the garage floor considered an attic area in the room below?
That's a great question, and really it's an interpretation question. Technically, if the garage door is closed all the time, that is going to be an unconditioned space versus an outside space, and it will never be as cold as outside. And so I have allowed less than R38 insulation on that quite often. The other thing that you have to take into account, and the code doesn't go there specifically, but that's a mass, you know, a concrete slab. And so comparable insulation levels to what you would put on one side of a slab, you know, a slab wall, you know, a concrete mass wall would be applicable there. So instead of an R38, somewhere around a 24 or something like that on the underside of that foundation, excuse me, that garage slab, whether it's precast panels or cast in place, would be an interpretation I'd give.
Great, thank you, Brent. We have another question. Just so everyone knows, we have The first question came from Brian Taylor. Thanks, Brian. The second question was from Russ Kolazzi. This third question for Bob Bennett. Brent, can you talk about swimming pool covers for code compliance?
Okay, swimming pool covers, and I'm pulling some of this off the top of my head, Bob. There was an attempt a code ago to make all swimming pool covers insulated. Well, it's virtually impossible to do that. So the swimming pool cover now requirement, and that's if the temperature is 90 degrees or under, I believe, is it just needs to be a vapor barrier type cover that will cover the whole pool.
Another question, this one from Patrick Davis for Brent. Do foreign windows and doors have to have the NFRC stickers, and can the equivalent European standards suffice?
Quite honestly, I'm not familiar with the European standard, but thermodynamics is thermodynamics, so I would assume we have an ability to convert from U-factor to whatever standard they might use. The U-factor virtually tells you that you will have, if you take the U-factor times the temperature difference, you get how many BTUs will be lost to a square foot. And so what I'm trying to say is, yes, we could make it work. You're going to have to bring some certified data, and I don't see any problem with making a judgment on what's it equivalent.
The question from Cameron Barney. How do we look at under garage rooms?
This is a little bit from before. An under garage room is typically completely surrounded with concrete. I have them regularly that they don't want to insulate, but they want to condition. So you really treat it as a basement room. The walls are basement walls and insulated accordingly. Your floor, like we talked about earlier, depending on how you insulate it, you can get away with less insulation than you would on a typical attic because of the mass. And if you do it continuous insulation, of course, you could reduce it significantly there. An R25 continuous insulation is equivalent to an R38 with lots of breaks in it, for framing members. The other issue that you have to think about on theater rooms is outside the IECC, and that's ventilation. How are you going to maintain air quality in there when you don't have a window that you open? And that often requires mechanical ventilation through exhaust fans or heat recovery ventilators. If I'm not answering any of these questions enough in detail, feel free to shoot me a question. And while I've got the mic, Kevin, I've got probably 12 requests for the presentation. I believe you are going to send a copy out to everybody. Is that correct?
Yes, that's correct. I'll send a PDF copy of the entire presentation. I don't know if they make PDF copies yet, but yes, I will do that to everybody who registered.
Okay, and if you want additional information from either of us, Mitch or myself, please let us know.
Another question. How much does it cost to do a blower door test and to provide a report? So I guess that would be a question for Mitch to answer.
Yeah, so this one is obviously a little tricky to answer because it would depend on, the volume that the builder's is building, where the home is, that sort of thing, and whether or not it's truly that is all you're going to do. All you're going to do is do a blower door test and provide a report, and it's just a one-off, maybe $250. But if you have and that was really truly all you're going to do. But it just depends on, again, on what other sorts of inspections you were going to do, if you're doing other services provided, that kind of thing, and what the volume is. So that would really depend a lot.
Thanks, Mitch. So we have another question. Let's see, from Russ Kolazzi again. I hope I'm saying your name right, Russ. I am a certified rater. If I have employees doing blower door tests for code purposes only and not Energy Star, do they need to be certified?
So the current interpretation of the code, as we've all been discussing it, yes, they would need to be certified of some sort. You know, as mentioned, there is an out for, you know, blower door manufacturer. If the blower door manufacturer comes up with a training program that they can, you know, give and you can take and prove that you've taken it, that would be compliant. But to our knowledge, there's no such thing yet. So currently, yes, each person performing the blower door test for code compliance would have to show, you know, say ResNet or BPI. Some of the BPI standards are a little more less stringent than ResNet right now. But current interpretation is yes, each person doing this for code compliance would have to show some sort of certification.
So then there's a follow-up question. Does each person need to be certified or one employee of the company be certified? Which it sounds like kind of already answered.
Yeah.
So there are two questions, additional questions from Brian Taylor. So one, when can you test the ducts? And two, what happens if the home fails to meet the minimum requirements when the blower door test is conducted?
So for the ducts can be tested at, you know, during the rough. If there's no air handler installed, it has to be less than 7% duct leakage. And also at rough, but the air handler is installed, it has to be less than 10%. And at final, it has to be less than, you know, 10% as well. So you could either do it at one of those three stages, and then show compliant, you know, show what the rate was then. Keep in mind that if you test it at rough at 10%, typically if you retest it at final, you would show that it would show to be leakier. So, you know, keep that in mind. But it's legal to test at any one of those three stages.
Just commentary here, it sounds like the best time to do the test is earlier.
Yeah, I would highly recommend you do the tests at rough. That way, if you have to fix something, it's a lot easier to fix it then.
So the follow-up question from Brian was, what happens if the home fails to meet the minimum requirements when the blower door test is conducted? So
you got to fix it. There's just no way around it.
Great. Another question from Patrick Davis. Where can I get a clear definition of the prescriptive method? Let's maybe have Brent start with the answer, and then Mitch, if you have anything to add.
Sure.
Well, the prescriptive method is basically that table, 402.1.1. You basically, each component of your envelope meets the specific requirement for that. You can't have one component that does not comply. If you have one component that does not comply, even though you have others that are better, the prescriptive method fails. Then you would have to go to a trade-off where you trade off between the weaker, you know, the better for the weaker, and you know, the kind of averaging out so the total overall performance is equal. Yeah, there's the prescriptive table. If you're Climate Zone 5, just make sure everything meets these requirements all the way across on the line for Climate Zone 5, and make sure you meet the footnote requirements that are part there. That's the prescriptive path right there. However, the mandatory requirements further on in the code for air sealing and such have to take place. If you know, the prescriptive table does not excuse you from meeting the air sealing requirements.
Right. So if you buy yourself a copy of the IECC 2012 and then take the Utah amendments and, you know, redline your copy, basically you just want to be reading and following sections 303 through 403, and that's, you know, those are the sections you want to pay closest attention to.
Okay, we have another question from Scott Johnson. If a crawl space is conditioned, is it counted in the floor area to determine the minimum percentage in the duct leakage equation?
It would, yes, it would count as part of the volume. So, you know, obviously the ceiling height for that would be, you'd have to do a different calculation for the ceiling height. But yes, you would have to count that as part of the volume. And the same for a basement. So if you're indirectly conditioning a basement, that counts towards the duct test volume you're having to test against.
Thanks. A question, it looks like there are a couple from Darren Austin. The first, is ductwork in the garage considered outside the conditioned envelope if it is framed around and the framing is insulated?
From what, oh, let me look at the question. Ductwork. Yes, that would be outside. That would be outside conditioned space, so that would count towards the 50%. The 50% length.
Let me interject something there. The only way you could get out of that is if you created, and correct me if you think I'm wrong on this, Mitch, if you created that insulation wrapping around the ductwork so that it was complete six-sided enclosed insulation, so that you brought that thermal envelope completely below that ductwork. And that's going to be real difficult.
Right.
So the next question is the duct blast required at the four-way inspection or for final, which you kind of addressed?
Yeah, you can do it either way, but I recommend you do it earlier so it's easier to fix if there's a problem. And starting out, like for a lot of HVAC crews, the first time they get tested, they're going to fail. I got guys every day who said, oh, I've been doing this for 30 years. This is going to be the tightest damn ducts you ever saw. We test them, they fail, and they say, how is this possible? We put fog into the ducts, and then there's fog everywhere, and their jaws will drop every time. So especially starting out, I really recommend you get people in at rough.
We had a question come in from Diane Nelson. I think that it's already been addressed by Mitch with respect to cost on an average home, 2,500 square feet, and also duct blaster test on a similar sized home. Do you have anything else to add to your previous question? Answer?
Not really. I mean, it's really going to depend. If you add both, you know, a duct blaster test adds a lot of time to how much effort and time it'll take to do the testing. But yeah, it's really going to depend on the volume of the builder, where's the house is at, that kind of stuff, and what other things they're going to be doing for the builder.
Kevin, can I interject something here, please?
Yeah, go ahead.
Everybody out there heard a $250 number, and don't remember that number as the only price that will ever apply to a duct test or a lower door test or whatever. In fact, we talked about this yesterday, giving prices. You give a range from $250 to $500, and no one's going to remember anything but $250. So bottom line is, Mitch can't give you an exact price because he doesn't know your specific application. Yeah, the average or the typical might be there, but yours might be more. It could even be a little less if you have three of them right next to each other or whatever, you know. So you got to be a little bit careful with that. The thing that, and Mitch, you can tell me if this is wrong or right, but what I'm hearing across the country, areas that are doing a lot of testing, and so their tester is in one little area and stays in that area all day, the prices start going down because the efficiencies of just going from one to another rather than doing one on one side of the valley and then one on the other side of the valley.
Yeah, absolutely, I agree. So like if it's a multifamily building where we can go out there and we can test, you know, 15 in a row, you know, obviously, you know, the prices are going to be less. If it's a house where we've got to make a special trip out to Grantsville or, you know, somewhere far, you know, and it's just one test, you know, prices got to be higher. It's just the way things work. And yeah, the $250 thing, that was like for just a blower door test, not a duct blaster, and it's just a one-time visit. You know, maybe that'd be a price. Maybe. It just totally depends. So you're going to have to work it out with whoever you contract with.
So we have about 6 or so more questions that have come in, and it looks like we have about, well, we have almost 20 minutes left. So thanks everybody for sticking around and, you know, and submitting so many great questions. I'd like to get through the rest of these questions if we can, and then I have 3 more poll questions for participants before we adjourn. So the next question from Brian Orgo: will knee walls be required to be 2x6 to correctly obtain the R19 requirement, since the air barrier is required on the backside? I'd say both. Mitch, Brian, any thoughts?
Well, you know, not necessarily that you'd have to have a 2x6. You know, you could do a 2x4 and then do exterior, you know, you could do rigid insulation, add it to a 2x4, or you could do some foaming and still work with a 2x4. But what won't work is trying to stuff an R19 bat into a 2x4 and then call it an R19, you know, wall, because it's not performing like that and it won't work like that. So, yeah, yes and no. Brent, you got anything to add?
Just exactly what Mitch said. If it requires a 19, you can put 13 in the cavity, and you can put R5 on the attic side of continuous insulation, and that would meet just like it would any other wall.
Great. Another question from Brian was, why are some municipalities not accepting the prescriptive method?
I guess that's for me, and quite honestly, I don't know. The code is very specific that you can use one of 3 methods, and I know some like res check and some like prescriptive. In our jurisdiction, we get a lot of res checks turned in that are incorrect, but they didn't even need to turn one in because the house was 2x6, it had great windows, it had great attic insulation. They didn't even need to go down the res check line because they weren't trading anything off. They met the prescriptive table. So either that's their interpretation, but in my opinion, that's not what the code says, and I think that's an accurate interpretation from all my discussions with people around the country.
Would kind of follow-up comment and I guess question is, would it be just a matter of documenting on the plans, you know, where the home has those requirements from the prescriptive table and the other mandatory requirements?
You know, I would love it if a plan was turned in and on one of the pages they had a big table or something, or they just took a corner of the plan. In fact, we make notes, we put stickers on plans, but if a plan was submitted and it says energy compliance by the prescriptive method, and then it went down and identified the R values and U factors specifically as good as or better than the prescriptive table, and then make sure that your plans reflect that. In their details, the wall insulation on your details matches those requirements. Oftentimes, and I've got to give the inspector, the plan reviewer, a break on this and not be too hard on them, because they might have a plan turned in. The guy says, I'm going to meet the prescriptive requirements, but the details on the plans don't show that. They don't show slab edge insulation. They don't show R19 or whatever. So, yeah, be very specific on your plans. If you do a good job on your plans and you're showing compliance and it's simple and easy to find, I think your problems will be gone, and it'll be very easy to comply and to get it approved at review.
Thanks, Brent. Another question from Jessica Garner. For the Thermwise rebate, will the information change that we need to send in with the code change, or will it stay the same?
Yeah, there are some changes probably coming this summer. Both rebates are changing their tariffs just a little bit. But that would be something that you need to talk directly with your rater about. It's kind of outside the scope of today's conversation.
Yeah, and the new homes energy efficiency program team with both Questar and Rocky Mountain Power would also obviously be good sources for that. We have a question from Trent Sorensen. How much heat is lost through the walls of a heated swimming pool? Are there insulation requirements for this?
No, there are not.
Short and sweet answer. I like that.
Oh yeah, well I'll give Trent a bad time for asking the question anyway.
We have a question from Nathan Cranford. On a non-vented attic space, will a smart membrane product work in lieu of closed cell foam?
We are accepting that in our jurisdiction. I believe most of Wasatch and Summit County are accepting a smart membrane in lieu of the air impermeable insulation in a roof rafter. However, it has to be installed per the membrane manufacturer's requirements. We've had them in our jurisdiction where they did not install it per the manufacturer's requirements, and they said, oh, well, if I knew you're going to make us do it according to the requirements, it's going to cost more money. Well, why would you install a product not in accordance with the manufacturer's requirements? So, yeah, you can, each jurisdiction is going to have to make that decision. That's an alternate method that they're going to approve, but you're going to have that discussion with each jurisdiction. We accept it.
Let's see, we have a question from Rick Marshall. On the bonus room sloped ceiling areas, are they considered walls or ceilings?
Ceilings, yeah?
Yes.
Great. So the answer to this question probably is pretty long and in-depth if we wanted to go into the whole thing, but from Diane Nelson, great question. If a house does not pass a blower door test, what corrections are being done to pass the test?
Right. Well, there's a lot of, if you're working with a good rater, they should be able to, point you in the directions of things you'll need to change to your current spec that will get you to pass. And if you get on it right now, you have them go test, the last couple houses you just did, see how they passed, and then they could help you figure out what to do on houses going forward. But after July or whatever on houses that pass, or if houses fail blower door test, there's sealing you can do. If the carpet's not in, there's some easy fixes. Frequently there's easy fixes along rim joist areas. There's easy fixes along penetrations and other areas that can be fixed. But yeah, we could have a pretty long conversation about that. But I think the real answer for this conversation is just get involved with whoever's going to be doing your blower door test right now and kind of figure out where you're at now so that you don't have problems going forward.
Question from Bruce Mia. Is it advisable to have the general contractor and or appropriate subs on the site during testing? Any thoughts on that, Brent or Mitch?
Yeah, I mean, especially for ducts, the first couple of duct tests, having the HVAC guy there who's going to be doing it, and the superintendent or the general contractor, especially for the duct test, having them there for the first couple is a great idea. Yes.
Let's see. Another question from Nicholas Kalezi. Sorry, I just saw the other question come in. From Nicholas, if attic dams are so important, why does nobody use plywood or wood to do them? Insulation companies have to do them using poly, Tyvek, or cardboard materials that get smashed with the blowing hose when you blow in the attic. So I guess, what is the extent of use for, plywood or wood in attic dams compared to other materials?
So we're talking about the attic baffles to keep insulation from getting going up against the subdeck here, I believe is what we're talking about. You know, it's a great point. If they're installed correctly, you know, there's not enough force that it'll usually get crushed, but it does happen occasionally. Go above and beyond is a great idea, but you know, we're just talking about what the code requires, and you know, that's all the code requires, so that's what we're stuck with. And so, you know, a cardboard dam or attic baffle is all that's required to meet the code, so that's what we're stuck with. Though if a code official goes up there and sees that it's not installed correctly and that it's been crushed and it's not working, you know, he can red tag that.
I have a comment on that, Kevin. The code actually says in 402.2.4, a wood-framed or equivalent baffle or retainer is required to be provided when loose fill insulation is installed. The purpose of which is to prevent loose fill insulation from spilling into the living space when the attic access is open. And so the code does not allow, I think this went in a code cycle ago, maybe in 2009, it has to be substantially solid. I mean, wood framed or equivalent, I'm going to interpret that it's got to be strong enough that I can put my hands on it, push myself up into the attic and such. So I would not allow a cardboard baffle around an attic access.
Yeah. Okay. Yes. If we're talking about like the attic hatch, yeah, I'm with Brent on that one. Absolutely. Yeah, it's the attic hatch has to be plywood. Yes, correct.
And I don't know if that was his question or not, but that's what I perceived it as being.
Yeah.
Great question, Nicholas. Thank you. So a suggestion came in from Becky Robbins with Rocky Mountain Power, the WattSmart New Homes Program, and great point. She wanted to remind everybody that both the Rocky Mountain Power WattSmart New Homes Program and the Questar Thermoist Builder programs on their websites, they have a list of all the raters you know, who do work on their new homes programs. That's a really great resource for you know, for builders, or if a building department gets questions, you know, for them to use as a reference list, and that's just wattsmart.com and thermoist.com. So please use those resources to you know, to let people know, you know, what raters are out there, because there's quite a good list across the state. So we have one final question, and this will be great timing, and then we'll do 3 last polling questions after this question. How are we addressing the combustion air duct into the home with regards to tightness of the home?
Yeah, so testing protocol is you're not supposed to plug that. So if you're doing a blower door test, yeah, you have to count that as part of the leakage. So you shouldn't be stuffing anything in there to try and put your thumb on the scale. Also, along those lines, we frequently see those combustion air ducts wildly oversized. You know, we'll see like a 5-inch duct going in when it's just a water heater is the only thing that's actually going to be requiring that combustion air. So that'd be something to talk to your engineers about, to right size that if you're using a 90% efficient furnace.
Let me add just a little bit to that. If really, I think that a case can be made that the code says you have to seal the envelope, and if you have an open combustion air duct, it really isn't sealed. The 2015 code we did push through with Wendy Johnson's help and a number of others. For the 2015 code, open combustion air ducts will be required to be enclosed in rooms that are sealed, just like any part of the other thermal envelopes, so it'll be a complete different environment. And really, the code says that in several places, and it's going to make it a lot harder to pass with that open combustion air duct. Kevin, I have just a couple other points. If I have a minute or two, is that all the questions?
That is all the questions. Yeah. So please do that, and yeah, share your other points, and then we'll go to our final 3 poll questions for participants.
Okay. The first one I want to talk about is Mitch and I have both talked about verification, you know, the comprehensive inspection checklist. If you spend some time looking at that checklist, it is going to require some real coordination between code officials and builders on how all of those inspections are going to take place. And pictures might or might not be the solution, because how do we know if that picture is for that house that is under consideration at that time? So it's a real big concern on, are we going to do 10 inspections? Are we going to allow pictures on some things? Are we going to trust you on some things? So that's a discussion that's going to have to take place with the jurisdiction where you're building your house if you choose to do that comprehensive inspection rather than testing. And it's another reason to consider testing, because it's simpler. The one last thing, I know Bruce Mia from Office of Energy Development is on. I'm traveling to St. George next week to do some all-day training in that area. The state and DOE have provided some funding to Salt Lake County to offset travel expenses and such for me to go around and do some traveling, and so I am going to be available for various groups across the state to provide some individual training in your location. So keep that in mind and get in contact with me or talk to your local chapter or whatever, and we can facilitate some additional training on this. And that goes across the whole state.
Brent, follow up on that. Is there a website or a document that will be distributed that has the dates and locations of those upcoming trainings that we can share?
Well, we don't have a website at this time. Corey Bundy, Santa Clara building official, has contacted me and put the one together, and he is advertising it down in his area. I've been down and done one for before this program was available for the Southern Utah Home Builders, and this program's just been available for the last month or so, and but I guess maybe you could help us announce some of those. Is that possible, Kevin?
Yeah, Utah Clean Energy would be very happy to help announce those and get the word out about when those trainings are coming up. Absolutely. One thought on the first point you made, Brent. I'm not an expert in this, but when a rater or someone doing the tests is maybe using photo documentation, Mitch mentioned the idea of geotagging or GPS tagging the photos, so you can provide some more assurance that they're from the right property.
That's great. It's just taking pictures. It's a rough thing to do, because you really don't see the whole picture sometime on some of the things that people want to take pictures. They want to take pictures of rebar insulation in a foundation, or rebar installation in a foundation, and you don't see the whole foundation. If it's a specific point or a component in a house where a dryer vent goes outside or something like that, I imagine that you could work with your code official on that, but it's not a promise. You're going to have to work with your code officials on each one of those and come up with a procedure. You're going to work together as a team to do that.
Thank you, Brent. Thank you to everybody for submitting those questions. And if you can stick around for about 2 more minutes, I just would like to have these polls launched. So I'm going to put the first poll up. First poll is really kind of a contrast to the question about your level of understanding on the Utah Residential Energy Code before the webinar. We're hoping that this, the information that Brent and Mitch provided and this discussion and the questions answered some questions for you and maybe helped improve your understanding. So I'll leave that open for just about 20 more seconds, and please, as many people as can, please respond to that poll. Of course, this is just 2 hours, so we're not able to cover everything in the type of detail that will be made available in future trainings. But hopefully this did get some of you a better understanding of this new code that's going to be taking effect in July. It looks like we have over 80% having voted, so I'm going to close the poll. And let's see. And it looks like we have only 2% with little or no understanding, over 50% with a good understanding, and still some understanding, almost 50%. So actually don't remember what the first one, the first poll results were.
About 60-40.
60-40. Okay, so little change. Let's go to the next poll before we wrap up. This is, this question is really just getting a sense, from all the participants in thinking about what kind of quantifiable and maybe non-quantifiable benefits that the Energy Conservation Code brings to just kind of general well-being of home buyers and home occupants. Just kind of your personal thinking of the importance of the Energy Conservation Code as a mechanism to kind of protect general well-being of home buyers. I'll leave that open for just a moment longer, and then we'll get to our last question. For those who have already voted, our last question deals with potential future topics for trainings. Looks like we have most people voting in that second poll. And good news is that, almost, over half have an understanding that the Energy Conservation Code is very important to the well-being, general well-being of homeowners, home buyers. And if you add the somewhat important, we have a pretty good level of importance. And I would just make the comment that I think that's consistent with the intent of all the codes, is to really protect general well-being of home buyers. The last poll question, we're looking at, we want to get a sense if there are, of this short list, are there specific code trainings that are still highly valuable that that there would be demand for? Unfortunately, we don't have an open-ended question here, but there will be a survey coming out, which will be emailed to all the participants after the webinar is closed. And if you have other thoughts about additional trainings that would be helpful, please feel free to put that in your responses to the survey. Or you can let Brent and myself and others who are relevant contacts, let others know if there are other topics that are really important, and we would be glad to help facilitate that. Okay, we have almost 80% voting. I think I'm just going to close this for the sake of time. Maybe a couple more seconds. I close the poll, and it looks like there's quite a lot of interest in training on the performance compliance method. About 40% of you said that would be a priority. Also, the ACCA manuals, J, D, and S, not surprising. And less interest in training for commercial buildings, but I would guess that this audience maybe has some more of their focus on residential versus commercial for one reason or another. Well, with that, I would like to thank everybody who participated in today's webinar. And again, the presentation will be emailed to everybody. I'd like to thank Brent Ursenbach and Mitch Richardson for taking the time to prepare the presentation and to provide the presentations today. And just again, another reminder, there will be an email coming out with a survey. Please share your thoughts so we can make these kinds of trainings and offerings more as useful as they can be in the future. And with that, I will close the webinar. Thank you to everyone for participating.